Good day everyone. Today I will be discussing to you on how to convert degree measures to radian measures. So let's have the following problems. Convert the following degrees to radians. So degree measure to radian measure. To convert, we're just going to multiply pi over 180. Okay, we're going to convert degree to radian. So multiply to pi over 180. Then we're going to simplify. So we have cancellation method, 60 and 180. This will become 1 and this is 3. So we have 1 times pi. So we have pi all over 3. So that would be our answer. Pi over 3 radian. Other one is convert 125 degrees to radian measure. So again, multiply it to pi over 180. So they are divisible by what number? Divisible by 5. So we have 5, 10, 15, 20, 25, 30, 35, 45, 50, 55, 60, 55, 70, 75, 80, 5, 90, 95, 100, 5, 10, 15, 20, 25. So we have 25 times 180 divided by 5, that is 36. Can we still simplify 25 and 36? No. So our final answer is 25 pi over 36. And our last example, 85 degrees to radian. So times pi over 180. So they are divisible by 5. 5 again. So 5, 10, 15, 20, 5, 30, 35, 40, 45, 50, 5, 6, 5, 7, 5, 80, 85. So that is 17. Oh, and this is 36. So we have 17 pi all over 36. So that's on how to convert degree measure to radian measure. Just multiply it to pi over 180. Now let's have exercises on how to convert radians to degrees. So let's have the following. Number 1, 2 pi. We're going to convert into degrees. Now to convert, just multiply it to 180 over pi. So multiply it to 180 over pi. Pi will be cancelled out. So we have 2 times 180, that is 360 degrees. Next, number 2, 3 pi over 2. Same step, multiply it to 180 over pi. So cancel pi. We can also cancel 2 and 180. So we have 1, then 90. Now we have 3 times 90, that is 270 degrees. And last, pi over 4. Same step, multiply it to 180 over pi. So cancel, cancel. Now 180 and 4 divisible by 4. So we have 1, then 180 divided by 4, that is 45. So 1 times 45, so 45. So that's on how to convert degree measure to radian measure and vice versa. Just multiply it to 180 over pi or pi over 180.
Welcome to Senior Pablo TV. Today we will be discussing the arc length. So first let us define what is arc length. It is the length of the arc intercepted on a circle of radius by a central angle of the measure theta radians is given by the product of the radius and the radian measure of the angle. Thus we have the formula, the S, the arc length, is equal to radius times the theta or the central angle. So this is the arc length. R is for radius, stands for radius, and the theta is our central angle. So to illustrate, let's say we have this circle and we have here 30 degrees as our central angle. So when we say angle, it is an angle formed by in our with the vertex in our center of the circle. So let's say we have this 30 degrees. So where is the arc length there? So we have here, this is what we call the arc length. And of course, this is our radius. In our circle, all the radius have equal measure. So they are equal. This is our sector or the arc length. If we're going to use this formula, we can derive two more formulas. So S or arc length is equal to R times our central angle. If you want to find the radius, we just need to divide by theta or central angle. So cancel. Radius now is arc length all over the central angle. The second one is, if the central angle is missing, the same step, divide by radius. So central angle is equal to S over R. These will be the two formulas that you're going to use. Now let us try some application. Let's try to solve some word problems regarding this topic. Now let's try to solve some problems regarding our topic, the arc length. Let's have our problem number 1. A circle has a radius of 20 centimeters. Find the length of the arc intercepted by a central angle having a measure of 3 pi over 8. First step, write all the given first. So given, we have the radius, 20 centimeters, and our central angle, 3 pi over 8. We're going to find the arc length. We know that we have the formula, S is equal to pi theta. So S is equal to 20 times our central angle is 3 pi over 8. So 3 pi over 8. Cancellation method. So 20 and 8 divisible by 4. So 4, 8, this is 2. And this is 5. So we have 5 times 3. We have 15 pi over 2. This will be the measure of our arc length. 15 pi over 2. Now our second example. A circle has a radius of 5 over 2 centimeters. Find the length of the arc intercepted by a central angle having a measure of 70 degrees. Write all the given. We have a radius of 5 over 2 centimeters and central angle 70 degrees. Now convert our central angle into radian measure. So multiply it to pi over 180. Divisible by 2. So we have 90 here, then 35. So the equivalent is 35 pi over 90. Okay. So we're looking for the arc length. So that is equal to radius times the central angle. So the radius is 5 over 2 times 35 pi over 90. Okay. So cancellation method. So we now have divisible by 5. So 1, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 56, 55, 70, 55, 80, 55, 90. So we have 18. Now we have 1 times 35, 35 pi all over 2 times 18, 36. Now let us proceed in our problem number 3. Find the radius. Given the arc length 7 pi over 6 and the central angle 3 pi over 14. So our formula is arc length is equal to r times the central angle. We need to find the radius, so we need to divide by central angle or theta. Now we have r is equal to s over theta. This will be the formula that we are going to use. After getting the formula, we are now ready to substitute. So r is equal to s is 7 pi over 6 all over 3 pi over 14. Divide. So fraction and a fraction, copy the numerator. 7 pi over 6 times the reciprocal of our denominator, 14 over 3 pi. Can we use cancellation method? So pi will be cancelled out. So 14 and 6 divisible by 2. So we have 2, 4, 6, 3. Then we have 7. Now we have 7 times 7, that is 49 over 3 times 3, 9. So 49 over 9. If you want to write it into decimal, so divide, then write into decimal form. Now, in our last example, find the measure of the central angle. So our formula is S is equal to R theta. We're going to find theta, so we need to divide by R. Now we have theta is equal to S over R. Given the radius is equal to 15 centimeters and the arc length 2 pi over 3. Let us first convert this into degree measure. So multiply it to 180 over pi. So cancel. Divisible by 3. So this will become 60. 2 times 60, that is 120 degrees. Okay. Now let us substitute in our formula. Our S is 120. Okay, it's okay that we're going to use pi. Okay, 120 over 15. So that will give us 120 over 15. Reduce into lowest term. Divisible by 3. So we have 40 and 5. Again, we have 8. So 8 degrees. Now let us check if they are the same if we're going to use 2 pi over 3. So 2 pi over 3 times the reciprocal 1 over 15. So we have 2 pi over 45. We know that pi is equal to Then 2 pi. Let's check if we will get the same. Times 180 over pi. So cancel pi. Now we have 45 and 184. Oh, really same. 8 degrees. So the answer can be theta is equal to 8 degrees, or if you write it into radian form, that is 2 pi over 45. So that's the arc length. Thank you for watching Senior Pablo TV.